Hello friends, Mr. Burrell here. We're at the very end of Unit 10. We've been talking about different ways to solve quadratic functions. We've talked about the square root method. We talked about the zero product property and solving by factoring. We just finished talking about the quadratic formula when I have real solutions. The quadratic formula is a formula that will solve any kind of quadratic function, and today we're going to extend that to even when my quadratic function has complex or imaginary solutions. All the ones we did in 10.5 when we were talking about the quadratic formula, my solutions came out as real solutions, like numbers, decimals with negatives or positives or whatever. Today we're going to have some imaginary solutions, and we're going to take a look at what that looks like. So by the end of this video, by the end of this lesson, I hope that you are able to find complex solutions to quadratic functions using the quadratic formula. So, not all quadratic equations will have real solutions. Spoiler alert. Sometimes they'll have complex solutions. If you remember at the very beginning of this unit, I gave you a problem like x squared equals -9. And because there was just an x squared, not an x term by itself, I could use the square root method to solve that. However, because I have this negative underneath the square root here, whenever I have a negative underneath the square root, that means I'm going to have an imaginary number. So the square root of 9 was 3, and then since there's a negative underneath the square root, that's going to give me a 3i. And I also had, if I had a positive 3i here, I also had a negative 3i. We talked about at the very beginning of this unit, when we were using the square root method, when we had a negative underneath there, it means I had an imaginary solution. So, on the subject of solutions to quadratic equations, remember the discriminant? We talked about how the discriminant is b squared minus 4ac. If I have the standard form of a quadratic function, ax squared plus bx plus c equals 0, the discriminant is b squared minus 4 times a times c. And that told me what kinds of solutions I had and how many of them. So the situation was either I'd have two real solutions, one real solution repeated twice, or two imaginary solutions. We talked about if the discriminant is positive, I'll have real solutions. If the discriminant is negative, I'll have imaginary solutions. And if the discriminant was 0, I had one real solution repeated twice. So, take a look here at the quadratic formula that we've been discussing. Notice where the discriminant is. b squared minus 4ac right here. It's underneath the square root. Well, I mentioned before that if this discriminant is negative, that I'm going to have imaginary solutions. Well, that makes sense, because whenever I have a negative underneath the square root, that means I'm going to have an imaginary solution. Okay? So, something to keep in mind as we go throughout some of these problems. So we're going to set these up the exact same way as we did in 10.5. I have the quadratic formula right here, x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So in this quadratic equation, I first need to identify what is a, b, and c. Well, this is already in standard form, so a is 4, b is 6, c is 3. So let me go ahead and plug those numbers into the quadratic formula. X equals negative, parentheses, b, which is 6, plus or minus the square root of b squared, so parentheses 6 squared, minus 4 times a, which is 4, times c, which is 3, all over 2a, which is 4. So I'm going to put all those a's, b's, and c's in parentheses there. Okay. So, let me go ahead and pull up my calculator. I'm going to type just the discriminant, just what's underneath the square root. 6 squared minus 4 times 4 times 3. Let's see, parentheses, 6 squared minus 4, parentheses, times 4 times 3. That should give me my discriminant, which is negative 12. Negative 12 is my discriminant, or what's underneath the square root there. So all of this jazz right here turns into negative 12. Then out here I have negative parentheses 6, which is just negative 6, plus or minus the square root of negative 12, all over, and 2 times 4 was 8. Okay, so the only difference between this problem and some that we did in 10.5 is that now I have a negative underneath the square root. Okay, beforehand I could just type this straight into my calculator and I'd be done, I'd be set. But this negative underneath the square root, I can't type that in my calculator, so what am I going to do here? What's going to happen? So what I'm going to have us do, this negative, again, underneath the square root just means that I'm going to have an imaginary number. So this negative, instead of writing this negative underneath the square root here, I'm going to take that negative out as an imaginary number, as an I, and write it out in front of the square root. So my answer would be negative 6 plus or minus I times the square root of 12 over 8. And that is as far as I need you to simplify this. With the imaginary number, that's as far as I need you to simplify this. I would have negative 6 plus I times the square root of 12 divided by 8, and negative 6 minus I times the square root of 12 divided by 8. That's as far as I need you to go. I could technically simplify this a little bit more. If you're interested in knowing how to do that, come talk to me. I will show you how you can further simplify this. But this is as far as I'm going to require you to go. Negative 6 plus or minus I times the square root of 12 all over 8. Okay? Let's do another example. I have 3x squared plus 3 equals negative 2x. Well, before I do anything, I have to put this in standard form. Because in order to use the quadratic formula, in order to identify my a, b, and c, everything needs to be set equal to 0. So that means I should probably add this 2x on both sides, which would give me 3x squared plus 2x plus 3. I have to put the 2x before the 3 because that's what standard form looks like, equals 0. So now that it's in standard form, a is 3, b is 2, and c is 3. Okay, let's take a look at this. So I have x equals negative b is 2, plus or minus the square root of b squared, so 2 squared, minus 4 times a times c, 4 times 3, all over 2a, or 2 times 3. That's my quadratic formula. So, I'm going to type this business, just what's underneath the square root here, into my calculator. 2 squared minus 4 times 3 times 3. So, parentheses 2, parentheses squared, minus, what was it again? 4 times 3 times 3. 4 times 3 times 3, all in parentheses there. That gives me negative 32. So, right here underneath the square root, I'm going to have negative 32, and then I have negative and then 2, that just comes out to negative 2, plus or minus the square root of negative 32, all over 2 times 3, which is 6. Okay. Well, at this point, if this was a positive number underneath the square root, that would mean I would have 2 real solutions, and I just type that away in my calculator. I can't type an imaginary number in my calculator, though, so this negative is going to come out here as an imaginary number. So my final answer will be negative 2 plus or minus I times the square root of 32 divided by 6. Negative 2 plus or minus I times the square root of 32 all over 6. And that's as far as I need you to go. Again, if you're curious as to ways that you could simplify that a little bit more, feel free to come and talk to me and let me know. Okay, let's do one more. Let's see. I want to do this one because it's going to have some negatives. So I have 2x squared plus 1 equals 2x. And then I'll leave this one here for you to try on your own. So is this question right here, is this in standard form? No, it's not. It's not set equal to 0. I would need it to look like this. ax squared plus bx plus c equals 0. So I'm going to go ahead and subtract 2x on both sides, which will give me 2x squared minus 2x plus 1 equals 0. Okay, now that it's in standard form, I would identify A, B, and C. So A is 2, B is negative 2, and C is 1. Okay. So I don't have the quadratic formula written on this page, but let me write it out for you here. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. You can probably try to memorize that. There's a little clip on the Canvas page with a little catchy song to help you to memorize the quadratic formula. But with that being the quadratic formula, let me start filling in my blanks here. Negative b, and b is negative 2, so I'm going to put negative 2 in parentheses there, plus or minus the square root of b squared, negative 2 squared, minus 4 times a times c, all over 2a, or 2 times 2. So, again, I need to put this part right here into my calculator. So, negative 2 squared minus 4 times 2 times 1. Parentheses, negative 2, close parentheses, squared, minus 4 times 2 times 1. 4 parentheses 2 parentheses 1. Is that right? Yes. Okay. Well, that gives me negative 4. That gives me a negative 4. Okay. So, writing this out, I have x equals negative times a negative 2. That's going to give me a positive 2, plus or minus the square root of negative 4, all over, and then 2 times 2 is 4. Okay, well, if there wasn't a negative, if this was just a positive number underneath the square root, I'd just type those into my calculator as 2 separate answers. Since that's a negative underneath the square root, I'm not going to be able to type that in my calculator because this is going to be a complex or imaginary solution. So what am I going to do with that negative? I'm going to write it out in front of the square root as an I. So x equals 2 plus or minus I times the square root of 4 all over 4. And that's as far as I need you to go. Again, you can simplify this a little bit more if you would like to. For example, the square root of 4 just gives me 2, so you could write this as 2 plus or minus 2i over 4, and you could simplify that a little bit more. But this is as far as I need you to go for the purposes of what we're doing. Okay? Again, feel free to try this one on your own, a little practice using the quadratic formula. But that's it. That's everything that we're going to cover. That's the end of Unit 10. That's all that you would probably need to know about solving quadratic functions. So hopefully now, especially after this lesson, you're able to find complex solutions to quadratic functions using the quadratic formula. I hope that was helpful. Please don't hesitate to reach out to me if you have any questions whatsoever. And I hope that you enjoyed that as much as I did.